I'm going to get started with my first STEAM project that I did. I made some rock candy. So this project is where you supersaturate a solution. Let's start with, I'm going to share my screen with everyone here really quick. So the experiment that we ran, or that I ran and that you all get to join in on, is making rock candy. So what sweet science? We're looking at the chemistry of foods. When you're doing this, we're all chemists right now. We're all working with chemistry. This is my notebook. I encourage people, if they want to keep their own notebook. I'm going to have a few different examples of what it looks like to record things as a scientist, things to think about, and I'll be recording in a few different ways. With writing and with recording, it's always important that we know what were some of the questions we were asking, what we were trying to get at. So with rock candy, what we're experimenting with is how can we super saturate water? How can we make water take on way too much sugar so that we can make rock candy? So what we're doing is we're super saturating this solution, which makes it really unstable. We're forcing more sugar into it than we want to. And something I want to point out that I always do with my notebook, so some sort of title of the experiment you're running. I was interested in both comparing the chemical makeup of water along with sugar, and I usually put my date up at the top. Just helps you know, like, when are things happening, what's going on with that. And what we're really messing with here is La Chatelier's principle, which really just looks at equilibrium. Things want to stay the same until outside forces change it. And when outside forces start changing it, it goes in the opposite direction of the outside force. So it's happening, what we did, if you have your little packets, if you haven't yet, what you will be doing is you're heating up water and you're adding sugar to it. What you're doing, that outside force that's changing it, is temperature. You're changing the temperature, and water and sugar don't want to change temperature. So what they're doing instead is they're breaking apart that sugar molecule that's breaking, which means that it takes some of that heat, that energy when it breaks, and it cools it down just a little bit. So what it's trying to do is keep the temperature from rising. So to keep it from rising, it's like, I'm just going to break these bonds. It'll take up energy until we've got extra energy. Let's just break these bonds and we'll dissolve all this sugar into water. I don't know how many people have tried this, but I definitely did as a kid. I would always put sugar packets right into my water. And most of it wouldn't dissolve because it was cold, especially if there was ice in it. It just would not dissolve. I would just end up with an amount of sugar at the very bottom of my glass. And what we're looking at with this is that when we add heat, we dissolve more and it takes on way more of the sugar than it wants to. So La Chatelier's principle works in both directions. Once it starts cooling down, it actually is going to start forming those bonds again because it doesn't want to cool down. It wants to be that temperature. It doesn't want to change temperatures. I'm sure we've all experienced this where once we get going on something, we don't want to change. So you can think of it as a natural force, right? So it starts forming those bonds. And what we're doing here is we're trying to force it into making bonds and creating that sugar where we want it to be creating that sugar. So in this, I have a few different variables. There's a number of different ones I outlined in the packet. Variables, we can think vary. What am I changing? What is different? So we can vary the concentration of sugar to water. We can vary how long it takes to cool down. We can vary where we want to place it, in a sunny window, into a cabinet. There's a lot of things we can mess with here. And then once you've decided on what you're going to vary, I actually vary two things. So I vary both how long it takes to cool down and where to place a sunny window. I only wrote up my hypotheses around cool down time, not where I placed it. So I'll talk to you about what I did with the other ones. You want to create your hypotheses. You always want to start, and this is kind of counterintuitive to everyone, but you always want to start with a hypothesis that what you changed has no effect. Doesn't impact this at all. So your null is cool down time does not affect crystal growth. How long I let it cool does not affect crystal growth. So you'll understand better, like after you heat it up, how long you let it cool before you add what you want to put the sugar onto. Alternative is cool down time does affect crystal growth. And then from that, you create a more specific prediction. So my prediction was the crystal will grow larger when there is less cool down time. And then I have my observations from different days. You can draw, you can write this out. Any way you want to record this is just fine. So I'm going to bring you back to the experiment and what I did. I added a third of a cup of water and to a cup of sugar, which means that I did a 3-to-1 concentration ratio. 3 times as much sugar as water. That is a lot more sugar than it wants to take in, but you can do, this is one of the things that you can vary. You can vary how much sugar you add. You could add more, you could add less, you can compare those. You could also try to see how much sugar you can put in before, even with the heating up, it won't accept any more sugar. It just can't. It's chocked full of sugar. It will not dissolve. It's another way you can experiment with this. And then what you do from the instructions is you let it cool down. 1, I'm a little bit impatient. 2, I was thinking, La Chatelier's principle means that, I don't know if you can hear my chickens in the background, they're really excited to get out. If La Chatelier's principle means that it doesn't want to change, right? So it's going to start forming bonds really, really, really fast right when it's cooling down. Why wouldn't I want to start growing my crystal as soon as possible? So the first one I did, this is the one that I did not let cool down for like maybe 2 minutes. It was still hot. Here I have my toothpick. I created a little thing so it could sit up on top. You can be creative in how you do this. I tried this in a different way as well that seemed to work a little bit better. I have some crystal growth on here. What I found is it's not as good as the other one. I think this is because part of your experiment is seeding the crystal. So you want to tell the crystal where to grow. It's easy for it to start growing on other crystals, which is why in the directions it says you get whatever you're growing your crystal on a little bit damp, and then you coat it in sugar and let it dry. So this is really important because when you're letting this dry out, that's where the crystal want to start growing, which is why, and I'm pretty sure this is why my other one didn't work as well. You can see there's a pretty big difference. I would say this is like 2 to 3 times larger because when I put this in, my water was still hot. So it melted. It was still in that state where it's like, oh, we don't want to be quite this hot. So it broke apart my sugar bonds before I wanted it to. So when it broke apart those sugar bonds, it didn't work in seeding the crystal there. And it means that the crystal, you can see there's precipitates and crystallization along the bottom and along the top. This is part of the reason why I say you want to be careful that your stick isn't touching a wall because it could actually grow to the wall and become really hard to remove from your solution. So I found there was a very big difference in cool down time, and it makes sense when I think back on it. And that's what we're interested in as scientists. We're thinking, what can we change? Why does it affect it like this? We're always challenging our assumptions, what we think we know. We're trying to see like, well, what happens if I change this? And then I also did the sunny window versus in the shade. So I've got, this is the one I had in the shade. It had cool down time about 15 minutes and it sat in the shade. Well, this one also had cool down time, sat in a sunny window. What's interesting is yesterday, this one was larger than this one, but today this one's larger. I looked at this in the afternoon. Today I'm looking at it first thing in the morning. So I wonder how much during the day the sun may result in some of this breaking apart and then coming back together at night. Another cool thing you can think about looking into that I saw is try cool down time in the fridge. How does hyper cooling it down way faster affect this? So I could keep going with this experiment. One of the reasons I decided to stop today is I've got an ant colony that has found one of my rock crystals. So that's something to keep in mind when you're making this of what's going to find it? Where am I going to put this? It can be in a window, it can be in a cabinet, but just a thing to keep in mind that ants, which have a tendency to get in my house sometimes, definitely found mine. So here are some of the different things that you can be experimenting with. Something I want to point out, the longer you wait, the more rock crystal you're going to be having. And check on it kind of regularly. I have some that created like a solid skiff along the top of crystal. And that's going to make it hard to get it in and out. Like, so there's different things to just be checking in on. I encourage you to try different things. Let me know how they work. Keep a notebook on your findings. So we'll be handing out, this is my STEM book that I just made on my own. You can also do composer notebooks in a lab. You typically use one of those composer notebooks that you can't rip pages out of. That's because you want to take notes of everything that happened, good or bad. I would constantly take notes if I made a mistake, If I had an accident in the lab, there was once I was trying to run an experiment and the fire alarm went off. And right when I needed to do that next step, I was outside of the building. So I came in and I was like, I had to wait too long. I had to throw everything out, but I put that in the notebook. Or sometimes when I'm really trying to figure out how an experiment works, I'll just keep working through the experiment and I'll write down the mistake I made. I'll know it's not perfect, but it gives me an idea of what I'm working with. So this is mine. We have some really nice paper that you can put on the outside. I took some scissors and cut little triangles along here to run some ribbon through. I would leave a little extra space for your ribbon because sometimes I rip my notebook a little bit when I open and close it. And then I keep my results on my rock candy. Your notes, look however you want. Pictures can say 1,000 words. So thank you. I'm really excited to be doing science with you this summer. Enjoy your rock candy. It's actually pretty delicious. I wasn't thinking I was going to eat any, which is why I made such small amounts. But I tried some the other day and it really tastes good. Oh, one other thing you can add is food coloring if you have it, but I just didn't have any on my shelf. All right. Bye.